Okay, so the student is using this experimental setup to measure the amount of current that flows depending on how much light falls on this LDR. So, first question, state why the student takes her readings in a dark room. 1 mark. Okay, so, well, you would do, wouldn't you? Because you're changing the amount of light that falls on this LDR by changing the distance the lamp is from the LDR. So you don't want any other light in the room because it's going to interfere with the results. It's the idea of making it a fair test, okay? So for these sort of questions, try and show your knowledge that you know what a fair test is, and try and get the word fair test in the answer. Fair, you want to make it a fair test. What that means is that you want for all the readings that you take, okay, you want the only change of light intensity on the LDR, you want that to be completely controlled by you and nothing else like the background light in the room, okay? Right. So, complete the table, this table here. Right, so we have to give an example of a control variable, a dependent variable, and an independent variable. So, example of a control variable. Well, just like we've been talking about, you have to control the amount of light, the background light in the room. Ideally, it should be 0. So it's the same for all readings, all experiments. So it's a fair test. You have to make sure everything else is the same for all readings. Okay, so you could say the voltage, for example, that has to be the same for every single reading. So voltage, use the same LDR, use exactly the same experimental setup for all readings. Okay, right, let's do the independent variable next. The independent variable is the thing that you change, okay? So, in this case, we're changing the light intensity, okay? The amount of light that lands on the LDR. So, let's write that. Okay? Now, we're changing the light intensity by changing the distance that the lamp is from the LDR, okay? So you could also write distance there, okay? Yeah. Right, and the dependent variable is the thing that changes, the thing that you measure, okay? Thing that changes as a result of you changing the independent variable. And in this case, it's current. Good. Right. B. Results table there. Circle the anomalous reading. Okay, one of these readings is anomalous. Which one is it? Well, 100, 100, 102, 109, seems fine, 26, 25, 25. The 3 readings that the student's taken, they should be similar, okay? But look at this one, 3.9, 16, and then 3.8. It's clearly that one, because that's way off. That's completely different to the other 2. All the others, these 3 are similar, those 3 are similar, and so on, okay? Calculate the correct average current, okay? What you have to do is ignore the anomalous result, okay? And just take the average of the other 2. So the average of 3.8 and 3.9 is 3.85. However, all these results given to 1 decimal place, so that would become 3.9, okay? Good. So the average is no longer 7.9, it's 3.9. Right, plot the graph, 4 marks. Okay, so we're changing the distance of the lamp from the LDR and thereby changing the intensity of light on the LDR. So that is our independent variable, okay? And we're measuring current and taking the average. So this is the dependent variable. Okay. The dependent variable should go on the y-axis and the independent variable on the x-axis. Okay. So you have your graph and your graph paper. Now they gave you 8 squares on your question sheet on the x-axis and 6 squares on the y-axis. To get full marks for plotting a graph, you have to fill at least, or more than half of the available graph paper, okay? So at least 4 on the x-axis and at least 3 on the y-axis. Try and get it to fill as much of the graph as you can. You also have to label the axes and give the unit. So, what should we do next? So let's do the x-axis first. Right. Look at this. It goes 10, 20, 30, 40, 50, 60, 80. There's no 70. I don't know if that's a mistake on the exam question or if it's deliberate. Okay. I suspect that might be that should be 70, but that's what the question sheet said. So let's go with it. Let's just leave it at 80. So 8 squares up to 80, obvious what to do, right? 0, 10, 20, 30, 40, 60, 70, 80. Right, y-axis, it goes up to 104 and we've got 6 squares. Well, the best way to do it is to do it in steps of 20, because that takes up to 120 on the 6th one, and 104 out of 120, that's most of it. So 20, 40, 60, 80, 100, 120. And like I said, don't forget to label the axes. So the x-axis, you have to write it is distance from lamp and give the unit. So that's centimeters. Y-axis is current. And it's milliamps, isn't it? And yes, it's milliamps. Current is milliamps. Good, right, now just plot it. Be as accurate as you can. Right, so distance to lamp, 10, 104, 10, 104. I'm going to do my best, okay? I don't have a nice grid like you do, but you should be as accurate as you can. 10, 104, it's about there. 20, 25.9, 26, no, it's 25.9, 20, so that's about 30 there, so 26 is about there. 30 is an 11, 30, that's 20, that's 10, so 11's about there. 40 and 6, 40, that's about there. 50, 3.9, it's about there. 60, 2.8, 80, 1.5. Okay, there we go. And it says, right, well that's the graph plotted. Draw a curve of best fit for 1 mark. Okay. So, just do your best to get a nice curve, joining them all up. That's not bad, even though I say so myself. Good. Right, next. Describe the relationship between distance and current for 2 marks. Okay, between distance and current. So we have to describe this relationship. Okay. Firstly, say that as distance increases, current decreases. Okay, so write that out in a sentence. I'll do it shorthand here. So as distance increases, don't write that, you should write the word, okay? Distance increases, you can see that as distance increases, current goes down. So current decreases, okay? Secondly, for the second mark, this is a curve. It's not a straight line of any sort, okay? Which means because it's not a straight line, it's not linear. So therefore, it's non-linear. Okay, it's a curve. And that will get you your 2 marks, right? Don't expect to get a mark for saying something like there's an inverse relationship or an inverse square relationship. You won't necessarily get a mark for that with this question, okay? The question said describe it, and you've done that. But you don't know whether it's inverse squared, inverse cubed or whatever, so don't rely on getting marks for that. You get marks for saying that and that, okay? Right. State what happens to the resistance of an LDR when the intensity of light increases, 1 mark. Okay, well, you've just got to know this. You've got to know how LDRs work. The more light that falls on them, the lower their resistance. Okay, so the question says state what happens. You would simply state that the resistance decreases when more light falls on them. Okay? If it helps you remember it, which way round it is, does resistance increase or decrease, you can think of it as the light that falls on it as contributing to the current that flows. Okay? It doesn't really work like that, but if that helps you remember it, that's fine. It works by the more light falling on it, reducing the resistance. Okay. So, final question. Explain how the curve of best fit would change if the LDR were covered with a thin sheet of tracing paper. Okay, so if the LDR had a thin sheet of tracing paper, what would happen to this graph? 2 marks. Okay. So, for these questions, try and do it in order. So use the word therefore rather than because. Say this, therefore this, therefore this, if you can, okay? So, say something like, if the LDR were covered in a thin piece of tracing paper, less light will fall on the LDR for the same distance. Therefore, the resistance of the LDR will be higher, therefore less current will flow. Therefore, all the points on the graph at any distance, less current will flow, therefore that point will move down. So all the points will move down, so the whole curve will move down. Okay? And that's more than enough to get you 2 marks. Okay? Good. Let's just go through that again quickly. When you cover it in tracing paper, for the same distance, at any distance, okay, the light away from the LDR, let's say 20, then less light will fall on the LDR, therefore its resistance will be higher, therefore less current will flow, therefore that point will move down, therefore the whole curve will move down. Good, okay, so there we are. Not much more to say, I think. That's it. Thank you for watching. I hope you found this video helpful. If you did, please click the like button, and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drjem.com, and I'm also on social media. Thank you.